In today's video, we are going to discuss about the derivatives using quotient rule. So let's first recall about the quotient rule, then we'll solve many examples. So for the quotient rule, let f and g two differentiable function, then d dx fx over gx is given as gx whole square, means the denominator whole square, gx d dx fx minus fx d dx gx, which in other notations can be written as g f prime minus f z prime g whole square. So for this video, we will solve now examples using this rule, and it is need to mention here that whatever problem we will solve here maybe can solve by the other method, but we will strictly follow the quotient rule. Some cases we call division rule. So our first example is y is equal to x over x square plus 1. In the right hand side, I will recall each time about the rules we are going to use for the problem. So in this case, we are first use the quotient rule, and that's written here. So apply the quotient rule and we get this y dash is equal x square plus 1 whole square, and then write the denominator as it is x square plus 1, derivative of the numerator function which is x minus numerator function as it is derivative of the denominator function. Now here we are going to use the power rule, which is given as d dx x to the power n is equal n x to the power n minus 1. So using this power rule, we have the derivative as denominator as it is x square plus 1 whole square, x square plus 1, derivative of x is 1 minus x, derivative of x square plus 1 will be 2x. Then we'll simplify it and you have the final solution. Our next example is given as e to the power x plus x over x. As I mentioned before, this can be solved in other method, but we will follow the division rule, and for that we need to know the derivative of e to the power x, which is e to the power x. Now using this derivatives and the divisions rule, we have y dash is equal dy dx, which is x square in the denominator, and then x derivative of e to the power x plus x minus e to the power x plus x as it is derivative of the denominator function which is x. Now the denominator as it is x square x, derivative of e to the power x is e to the power x, derivative of x is 1 minus e to the power x plus x multiply 1. So now simplify that and you have the final answer. In the next example, we have some expression which is not ready-made as the division rule. So we first rewrite it to the format. We can apply the division rule as y is equal x square plus e to the power x, and e to the power minus x can be taken down as e to the power x. Now it is ready to apply for the division rule, but we will do one step more and further simplification before applying the derivative, so that we separate the terms and write it as x square e to the power x plus 1. Now we will do the derivative x square over e to the power x plus d dx of 1. So first one, x square over e to the power x, we will apply the quotient rule, and then we know that derivative of 1 is equal 0. So applying the quotient rule, we have e to the power 2x, e to the power x as it is, derivative of x square minus x square, derivative of e to the power x, and then write the derivative here, e to the power 2x as it is, then e to the power x 2x minus x square e to the power x. Take out the e to the power x and x common. So we have x e to the power x my 2 minus x e to the power 2x. Now again e to the power x in the numerator or denominator cancel out. So you have here x minus x over e to the power x. Our next example is the derivative of some rational function. Clearly, in this case, we can apply the derivative directly. So dy dx is equal to x square plus 4 whole square, x square plus 4 d dx of the numerator minus numerator derivative of the denominator. So which simplification, the denominator x square plus 4 whole square as it is, x square plus 4, the derivative of x cube plus 5x is 3x square plus 5, and the derivative of x square plus 4 is 2x. So now multiply them and the factor, so you get it 3x to the power 4 plus 12x square plus 5x square plus 20 minus 2x to the power 4 minus 10x square. So take the common terms, power of the x, so you will get it here x square plus 4 whole square, which then in the numerator you have x to the power 4 plus 2x 7x square plus 20. The last example is given as x square plus 3x plus 5 over square root x, which can apply the derivative rule directly as follows. So we have in the denominator square root of x whole square, then square root of x, derivative of x square plus 3x plus 5 minus derivative of square root of x and x square plus 3x plus 5 as it is. So we know that the power rule, what is the derivative of x square plus 3x plus 5, and what will be the derivative of square root of x, and we write it accordingly. Further simplification and rearrangement of the coefficients and power of x will gives us the final result.